Hello everybody, welcome back to another, you can say, informative session where I can share something which I have learned, and I welcome all of your comments and input so I can learn also. So this is one of my very favorite topics, that is network slicing, and I firmly believe that network slicing or differentiated services will be one of the key factors of monetizing 5G and actually revolutionizing the way we today see the networks. So let's dig into it. Today what I will discuss is two aspects, that how we design, or we can say how can we design a network slice, and secondly how does a UE camp want to a network slice. So let's do it. So the first thing is design, and there are multiple factors that you can see into a design of a slice. So what if you, first of all, what we need to look into is that how the network slice encompasses a network. So if you look at a network, it is RAN, it is transport, and it is core. A network slice is actually across these three components. To some extent, it is around transport. It's not exactly, you can say, slice based, but you can use different differentiation methods to get that effect. But on RAN and core, the specifications are clearly that we can make it slice specific. So when we are designing a slice, what we want to do, then it will have a direct implication on how we treat that slice on these particular two elements of the network. For example, we have throughput. So now throughput is directly a function of the resources allocated on the radio side, one thing. So what we can design is that we can have a particular design where we have some resource allocation meant for the slice in the RAN part. So that will be our design consideration for a particular slice, that if we want to have a differentiated experience on downlink or uplink, we have to secure some kind of resources for that slice on to the RAN side. How we function that, how we envision that is based on every product, but the idea behind is that there should be some kind of protection or some kind of allocation on the radio side. Another thing for throughput can be based on the transport side, that how we map the IP packets to be sent out from the GNOP, what is the preferred transmission link with less amount of loss, less amount of latency, and piggyback on that. And then on the core side, we can also choose our DNA based on our throughput requirements and any other requirements on the core side. Another thing, for example, for latency is a very interesting case, which kind of is a combination of both radio and core. So one thing that latency can exactly impact is that how quickly you allocate the resources. So that will go to the latency part. So how much resources you can allocate to that particular slice to secure those resources, so that uplink and downlink both the UE can communicate quickly, and it can also get the data to avoid any latency issues. Another thing which very interesting is from the core side, that if you look at my other video, I have provided the link you will see just right now, is from the core side. So based on a particular slice, you can actually allocate it to a particular UPF, to a particular SMF, and then to a particular DNN. All of these things can actually improve your latency. So for example, if you have not bought slice-based specific services, then when your UE registers to your NR standalone network, and be mindful that slicing is only for NR standalone networks. So it will get a default UPF, default SMF, and default DNN. But for example, if you have gotten a particular slice, so then in that case, your core network, once it gets the information from your repository function, it will allocate you as SMF. I can say it priority SMF, and then it will, from this SMF, it will give you another UPF, for example, UPF1, and then to a DNN. What can happen is that this UPF will be closer to the edge. That means that this UPF and DNN combination are closer to your user where it is using those services. It can be a gaming service, it can be a streaming service, it can be any service. And therefore, the latency, the end-to-end latency, which is your end-to-end latency, will be far less. So this is how the concept of slice design can be done in a network, that based on our particular use case, based on our particular product, we can implement this slice design onto the network. So let's come to the UE part. So the UE registration is also a very important part, that how a UE registers. So once the UE registers onto a particular slice, there are actually two modes currently being used. One is mode D and one is mode C. So in terms of 3GPP specifications, for the initial registration, we only use mode D, where the AMF actually tells the user that this is your allowed slice that you need to be registering on, and it registers the UE on that particular slice. So for the initial network registration, the slice information is only shared for AMF and the UDM. So for example, you have registered onto a slice A, then the AMF will check it to the UDM, and then it will go back to AMF, and the AMF will send out a registration successful message to your UE that you have been registered onto a slice A. The selection of DNN, UPF, and SMF happens when you send a request for a PDU. So that's your selection of the SMF. So once you send out PDU connectivity request, it will go to the repository function. Repository function will go to the SMF, and the SMF will actually decide your UPF and DNN. So as you can see in the UE registration part as well, that your slice design will come into play. That once you give a request for your PDU, that is to extract any data from any network, your SMF will be slice based, your UPF will be slice based, and your DNN will be slice based. It is based on the network, that either the network uses this or they use default SMF and UPF and DNN, and they only do the slicing based on your RAN functionalities, or vice versa, that there is no core function, there is no RAN functionality for slice, and all the slicing functionalities are implemented on the core part. But as you can see that the UE registration always goes through the AMF. So the slice definition, slice functionalities is primarily a core functionality. You cannot implement slicing in a network without slicing being implemented on the core part. Though you can have slices in the network while having no visibility or functionality for that particular slice in the RAN network. So that's why it's very important these days to learn the 5G core functionality, because as we move on towards monetization of networks, as we move on towards more differentiated you can say services, 5G core will become very important. And as we go towards the programmable networks as well, the SPS structure of 5G core and the slicing based functionalities are going to come into play significantly. I hope you enjoyed this session, and let's continue on our journey of network slicing. Thank you, and see you next time.